Dear students, very good afternoon. Today we are going to discuss very important problems under Cauchy's integral theorem. Already we have discussed the first important problem in Cauchy's integral theorem, and that problem was explained with the detail. Now I am going to explain some more problems, okay, in a very crisp way. Okay, so because the problems may be asked in 2 mark section, but unless you know the concept, it is not fruitful to do well in the examination. Okay, in order to perform well in the examination, you have to know the concept. Okay, see the problem. The second problem under Cauchy's integral theorem. Here we are going to see many problems. Okay, the second problem we are going to discuss, or we have discussed first problem. The second problem we are going to discuss here is evaluate. Okay, right, evaluate integral over C 1 divided by 2z minus 3 dz. Okay, evaluate integral over C 1 divided by 2z minus 3 dz if C is the circle, if C is the circle with modulus of z equal to 1. So what they have, so now we are going to see the solution. In the previous case I have explained a problem in high much of detail, but see what is necessary for the mark. Okay, see, listen. Into C f of z dz equal to integral over C, what is f of z? 1 divided by here they have given 2z minus 3, so I am going to take these two outside and it will become z minus 3 by 2 into dz, and that is equal to 1 by 2 into integral over C, f of z is 1 divided by z minus 3 by 2 into dz. Okay, why I have written like this? Because integral over C f of z dz, if I want to find, means the denominator should be in the format of z minus a. It should not be associated with any other extra constants multiplying with z, so I am writing it as z minus 3 by 2. So for that only I have taken 2 outside. If I take 2 outside, means it have to be divided, it have to divide that second term, that is 3. So that is equal 1 by 2 integral over C 1 by z minus 3 by 2 dz is the net result. Now this modulus of z equal to 1 means here they have given only modulus of z, so the radius is 1. We can simply draw the circle. It is circle, not oval, but it looks like oval. It is actually a circle. It is actually a circle, not an ellipse. Okay. Now Okay, how we obtain this circle? How we obtain this circle? Modulus of z equal to 1 means it is nothing but x minus 0 the whole square plus y minus 0 the whole square equal to 1 square. So center is 0 comma 0, radius is 1, radius is minus 1. So here it is r equal to 1. So this is x, this is y, this is our z plane. Okay, so z equal to 3 by 2. Z equal to 3 by 2 means, z equal to 3 by 2 means what will happen? See here, z equal to 3 by 2 means that is equal to 1.5. Okay, 1.5. This 1.5 will definitely lie outside the circle. Okay, so our conclusion is here. See, listen, f of z is analytic at all f of z is analytic at all points except at z equal to 1.5 and this z equal to 1.5 lies, okay, z equal 1.5 lies outside the circle modulus of z equal to 1 and f dash of z is continuous at all, second point, okay, at all points, okay, at all points inside and on C, which implies interval C 1 by 2 1 divided by z minus 3 by 2 dz equal to 0. So this is what they have given the question. Here just to modify it in the structure of interval C 1 by z minus a. Okay, because that structure is very important. 1 by z minus a structure, z minus a structure is very important. So later you will understand why the structure is important, because while we are studying about Cauchy's interval formula, you will see interval C f of z by z minus a structure. Okay, so now itself we bring that structure here. Okay, that's it. Okay, now but here the whole term is f of z. Okay, there we will have interval f of z by z minus a, but here this term, that 1 by z minus a, is f of z. Okay, so you should not get confused over these two things. So okay, now we have completed the second problem. Now we shall move on to the third problem. The third problem is evaluate interval over C 3z square plus 7z plus 1 divided by z plus 1 dz. Okay, where C is the circle. Always they will give C as a circle because that is a simple closed curve. Circle with modulus of z equal to 1 by 2. The value of modulus of z equal 1 by 2 means the modulus of z will be 0.5. Okay, now solution. See, I have to write the entire term in the following way. So interval over C 3z square plus 7z plus 1 divided by z plus 1 can be written as interval over C 3z square plus 7z plus 1 divided by z minus 1. Okay, z minus a, that should be in the denominator. Then only you can check whether z equal to a lies inside or outside this curve. Okay, this closed curve. That is why we are writing it in the form of z equal to z minus of minus 1. Okay, now what we will have, first point, z c f of z okay, simply I shall write simply. Okay, but you have to know the meaning. Z equal to minus 1. See, z minus a, z equal to a. Z equal to minus 1 lies outside the circle modulus of z equal to 1 by 2. Why? If I draw the circle, modulus of z means it is x minus 0. I have already explained how I get this equation. So you have to watch the first problem if you want to know why I am writing this modulus of z to be x minus 0 whole square plus y minus 0 whole square equal to 1 by 2 square, that is r square. Okay, so radius is 1 by 2. Radius is 1 by 2, that is 0.5, r equal to 0.5. Okay, so this modulus of this equation is nothing but modulus of z equal to 1 by 2, but they have given z equal to minus 1. Modulus of z equal 1 by 2 means plus z or minus z, plus z or minus z equal 1 by 2. So z equal plus 1 by 2, z equal minus 1 by 2, but z equal to minus 1 means it is more than the value of 1 by 2, minus 1 by 2. So it will lie somewhere outside the circle. So z equal minus 1 lies outside modulus of z equal to 1 by 2. Therefore f of z is not analytic at z equal minus 1, but it is not a problem because our curve is only about the points minus 1 by 2 to plus 1 by 2 in z. Okay, so f of z is analytic and this analytic means it is analytic everywhere over the curve C or inside the curve C, not the point lying outside curve. Okay, we are not supposed to worry for that. Okay, f of z is analytic. Simply write f of z is analytic inside and on C, or you can write f of z is analytic inside on C, or f of z is analytic and f dash of z is continuous. Both these are inside and on C, which implies interval over C. This f of z is 0. Therefore we get 3z square plus 7z plus 1 divided by, they have given z plus 1, but I am writing in the form of z minus of minus 1 equal to 0. Therefore, you can write the given question is also equal to 0 by Cauchy integral theorem, equal to 0 by Cauchy's integral theorem. Okay, now we shall move on to the next problem. See, for the 2 mark you have to spend only this much of time. Okay, I have explained the problem 1 with a very high level of explanation in order to make you to understand the concept. Okay, now the third problem. See, there are some functions where it is not possible for you to easily guess. So on such cases, what we can do? Okay, that is what we are going to see. The first thing is fourth 2 3 4. It is fifth problem, I think. Okay, it is fourth problem. It is our fourth problem. So write problem here is evaluate. You have to write evaluate interval c z minus 2 whole power n dz. Here this n is not equal to minus 1. Why? If this n equal to minus 1 means it will become the denominator 1 by z minus 2. If it is 1 by z minus 2 means it is not analytic z equal to 2. So the meaning of the question will get changed. Okay, will be changed. So in order to avoid that, they have given this n is not equal to minus 1. So where C is the circle given by modulus of z minus 2 equal to 4. So you have to write a question clearly. Evaluate interval over C. You have to write evaluate. Okay, you have to write that. Evaluate evaluate this function with n not equal to minus 1, where C is a circle with modulus of z minus 2 equal to 4. Now we have to do this clearly. What is this z minus 2? I have told you, when this is not associated with any other terms, you can simply write centers as 0. But here it is not, that centers are not 0. Okay, we shall check the center. Okay, this circle C implies modulus of z minus 2 equal to 4 means x minus 2, because both these are real terms, x minus 2 plus iy modulus equal to 4, that is square root of x minus 2 whole square plus y square equal to 4, that is x minus 2 the whole square plus y square equal to r square. Equal to 4 square. So center is there, so it is y minus 0 the whole square. Okay, this is, okay, so right here x minus 2 the whole square plus y minus 0 whole square equal to 4 square. So for this we will have a circle. See, if it is 0 comma 0 and this is 1 comma 0, this is 2 comma 0 means center is 2 comma 0, radius equal to 4. So I have to start at this point. Okay, 2 comma 0, from 2 comma 0 to radius 4 means 2 3 4 5 6. Okay, 2 to 3 3 to 4 4 to 5 5 to 6. So at 6 only our radius will get closer. Okay, and here you have to check minus 1. Okay, minus 1 0, then so it is not minus, it is plus 1 0 minus 1 minus 2. At minus 2 only you can see the curve will become closed, and it is no problem here. It is 4 in the y axis, it is 4 and it is minus 4. Okay, see, now we will have the circle. See, the circle have to be little bigger. Just think it is circle. Okay, it is circle. Okay, it is circle. Okay, now for this circle, okay, for this circle, how to check clearly? There should be only 4 points. 2 means 2 plus 4. 2 plus 4 is 6. 2 minus 4 is minus 2. It is minus 2. It is 6. It is 0 plus 4 is 4. 0 minus 4 is minus 4. Okay, the circle should cover only these points with the center here. Okay. Okay, now they have given z minus 2 whole power n. They have given z minus 2 whole power n. So it is not possible to predict what is that function. So what is denominator? If they have given n is not a negative function, n is not equal to minus 1, but n may be minus 2 or minus 3, whatever it is. So since n is not equal to minus 1 means definitely n will not become minus 1, so the denominator will not become z minus 2. At least if I put n equal to minus 2, I will get 1 divided by z minus 2 whole square. If it is z minus 2 whole square means, if it is z minus 2 whole square means I will get z square minus 2z plus 4. So the term will not become 0. Even if I put z equal to minus 4, it will become 4 plus 4, 8. 8 minus 4, it will be 4. So it will not become 0. If I put minus 4 means minus 2 square. If I put minus 2. Minus 2 square is 4. 4 plus 4 is 8. 8. 8, then it will be minus 8, so it will become 0. So for z equal to 2, it will become 0. For z equal to 2, it will become 0. Okay, but it is not in our hand. It may be z minus 2 equal to whole cube, z minus 2 whole square. Okay, so even for this problem, this diagram itself is not necessary. Okay, now simply write f of z is analytic inside and on C. F dash of z is continuous. Okay, f dash of z is continuous, therefore interval C z minus 2 whole power n equal to 0. CTS means continuous. Simply write that. Okay, now another problem. Now another problem. The problem here is e power interlog c e power 1 by z dz, where c is the circle given by modulus of z equal to 1, modulus of z equal to 1. So we can draw the circle, but it is not possible to bring the e power of 1 by z here. Okay, it will take many process. Okay, we have to convert this function with to the corresponding trigonometric functions. From the trigonometric functions we have to get r and theta, and that from r and theta we have to draw the circle. So if I do so, I have to convert this modulus of z to be that polar coordinate form, that is z equal to r e power theta form I have to make. So it is not necessary to do all those things. Simply it is 1 minus 1 1 minus 1, center is 0 comma 0, but see the solution. See the solution is very simple. Write those two conditions. F of z is analytic, inside and on C. See, simply write the statement of Cauchy integral theorem. F of z is analytic and f dash of z is continuous inside and on C. F dash of z is continuous inside and on C. Then it implies interlog C, f of z dz is 0, that is e power 1 by z dz equal to 0. Now another problem, our sixth problem. Evaluate integral over C x square minus y square plus 2y xy into dz over the circle C given by modulus of z equal to 1. See, again the same circle is going to repeat here. Okay, it is 1 minus 1 1 minus 1, so it is 1 comma 0 actually, and it is minus 1 comma 0. Okay, whatever it is, z plane it is. Now if I am having x square minus y square plus 2xy means it is nothing but x plus iy the whole square. Am I right? Okay, the given function is interlog C. You have to write interlog C x square minus y square plus 2y xy dz equal to this dz. Okay, what is this x plus iy the whole square? That is equal to interlog C z square dz. Okay, now since we are having interlog C z square dz, there is no denominator here, so f of it is analytic everywhere. So we can simply write here also there is no denominator. That is why it is not possible to say where the function is not analytic, because there is no denominator, which means the function is analytic everywhere. Here also the function is analytic everywhere. Okay, therefore we can write simply f of z is analytic inside and on C. You have to write inside and on C. F dash of z is continuous, which implies interval f of z is equal to 0. Therefore interval of C z square equal to 0, or interval of C the given function equal to 0. I am writing the given function as z square equal to 0, and then you can write this function. Okay, interval of C is equal to 0. You can write this to be 0. Okay, that after this you can write what is given a question, the same question, that is equal to 0. Now our second problem. Now this is our seventh problem. Our seventh problem is integral over C e power 2z divided by z square plus 1 dz, where C is the circle given by modulus of z equal to 1 by 2. So I have to write the denominator in a different way. So I am writing here solution integral of C, that is e power 2z divided by z square plus 1 is z plus I into z minus I, because generally you will get z square minus I square. I square is minus 1. Minus of minus 1 is plus 1. So it is z plus I into z minus I dz. Okay, z plus I into z minus I dz. When this z square plus 1 equal to 0, we can simply take z square plus 1 equal to 0 It implies z square equal to plus or minus 1. It implies z equal to, so z square equal to minus 1. Z square equal to minus 1. It implies z equal to plus or minus root of minus 1. It implies z equal to plus or minus I. So one factor is z plus I and another factor is z minus I. So we are having z plus I and z minus I. So f of z is not analytic at z plus I and z minus I, but they are lying outside the circle. So write both z equal to plus I and z equal to minus I lies outside modulus of z equal to 1 by 2. Modulus of z equal to 1 by 2. Therefore f of z is analytic inside non C. You write those two conditions. Okay, write those two conditions. I am not going to repeat the same thing here. I am simply writing, but you have to repeat the statement by Cauchy's integral theorem. But you have to write by Cauchy's integral theorem f of z is you have to write it later. F of z is analytic inside non C. F dash of z is continuous. Therefore by Cauchy's integral theorem the given question is having the value 0. Integral of C e power 2z by z plus I and z minus I equal to 0, or z square plus 1 equal to z square plus 1 dz equal to 0. Okay, this is our fourth problem. Our eighth problem, is interval C tangent or interval C tangent dz. Okay, they have simply given this. They have not given where it is over the circle and what about circle, whether it is z equal to 1 or z equal to 1 by 2. They haven't given anything like that. Just they have given evaluate tangent dz. Okay, this is interval C tangent dz. Now we are going to write a solution for this. We have to identify at some points definitely this function will not be analytic. Okay, but how to identify those points? We have to find the denominator. So in order to find the denominator, I am writing this tangent dz equal to interval C sin z by cos z dz. Okay, so this is our f of z. So in f of z we are having cos z. So the function is not analytic at the points where this cos z is become 0, where the cos z will become 0. Cos 0 is 1, whereas cos 90 is 0. Cos 90 is, I am telling the very basic thing, which is cos pi by 2. I am writing it as cos pi by 2 equal to 0. But not only at pi by 2, not only at pi by 2, for plus pi by 2 or minus pi by 2, for both the things we will get 0. Not only for pi by 2, for 3 pi by 2 also we are getting the same value. For 5 pi by 2 also we are getting the same value. So we will get the same value. So except at plus or minus pi by 2, 3 pi by 2 and 5 pi by 2, the given function is analytic. The given function is analytic. So we can tell the points cos pi by 2 means the points z equal to plus or minus pi by 2 comma plus or minus 3 pi by 2 comma plus or minus 5 pi by 2 etc. lies outside C. But they have not given C. But for any circle, the circle will not become infinity at any value. Okay, because circle is a closed loop, it is a closed curve. So these points where denominator becomes 0, the curve or the f of z will become infinity. So definitely this point lies outside C, lies outside C. Okay, and you have to write the statement f of z is analytic inside and on C, f plus of z is continuous inside and on C. Therefore by Cauchy's integral theorem we get, by Cauchy's integral theorem we get interval over C tangent or sin z by cos z equal to 0. I used to write the function f of z dz tangent dz equal to 0. Okay, this is our 8th problem. Now 9th problem. Now we are going to see our ninth problem. Evaluate. Our ninth problem is evaluate evaluate integral over c evaluate integral over c e power sine z square and then dz. Okay, now what is our f of z? F of z equal to e power sine z square. Okay, so we can make many functions here. Okay, sine of z square e power sine z square. Okay, so there are so many process behind this. This z square is x square plus y square. We have to do something here. Okay, but for 2 mark it is not going to explain all those things, but you have to write the conditions. So what is the condition? F of z is analytic inside and on c, inside and on c, and f of z it is continuous. Therefore, by Cauchy's integral theorem, integral over c f of z dz equal to 0, that is e power sine z square dz equal to 0. See, you have to write this dz, you have to write this z square, you have to substitute it with sine, you have to take the exponential for that. The exponential function, trigonometric functions are related by using there is a relationship between exponential function and trigonometric function. The relationship I shall give you a hint. Okay, x equal to, so I shall z equal to r e power I theta. Okay, z equal to r e power I theta. X equal to r cos theta, y equal to r sin theta, z equal to x plus iy. Therefore x plus iy equal to r e power I theta. Now you can see r cos theta plus x equal to y r sin theta, no, r cos theta plus I into r sin theta equal to r e power I theta. Okay, I am deriving this expression, how they are related. So r of cos theta, but this is not going to be useful for your examination. Cos theta plus I sin theta equal to r e power I theta. Both these all will get cancelled. Therefore e power I theta, which is exponential function, equal to cos theta plus I sin theta. So we have to make all these functions to be polar coordinates, and such that you can obtain, you can relate the exponential function and the trigonometric function. Okay, and the trigonometric function, then you can say f of z is analytic inside and on c, and f dash of z is continuous inside and on c, and finally you can tell by Cauchy's integral theorem. By Cauchy's integral theorem, integral over c e power sine z square equal to 0. Okay, so Cauchy's, the 2 marks on the Cauchy's integral theorem is very easy. even anyone can, even anyone new to this topic can also get full mark when they put equal to 0. At least they will get 1 mark even if they are not aware of the concept. Okay, so don't miss any single mark on this Cauchy's integral theorem. Okay, I hope you all enjoyed the problem. I hope you all enjoyed the problem. Okay, thank you. Thank you all once again. Can I go to this problem? I have verified that there is some problems for you to solve. I am going to give you some homeworks. Okay, or at least only one sum I am going to give. Okay, it's a simple problem. Take down of homework. Homework is evaluate integral over c 1 divided by 2z plus 3 dz, where c is a circle, given by modulus of z equal to 1. We have done a similar problem. We have done a very similar problem. Okay, we have done very similar problem close to this, but anyway, solve this problem. Yes, we have done 1 by 2z minus 3, but you have to do this problem. Okay, in the same way, evaluate integral over c integral over c 1 divided by z minus I the whole square dz, where c is given by modulus of z equal to 1 by 4. Okay, so evaluate these two. So these two are the today's homework. Okay, thank you all for watching this video. Thank you all once again.